Okay, so moving on to question 6, part A. It says power can be measured in watts. Define the watt. Okay, you just need to say the following. 1 watt is equal to 1 joule of energy transferred per second. With definitions, it's very important that you don't mix units with words. So you need to stick to one or the other. I've chosen a worded definition, but don't mix words and units. For example, you can't say 1 watt is equal to 1, and if I was to not write the word joule, I was just to put a J, that's mixing units and words, and the example words don't like that, so you need to stick to one or the other. Whoops, don't know why that came up there. Okay, let's just try and get a feel for what this means, watts. Okay, so if we have something, I don't know, let's take for example a kettle, is the sort of an average kettle is about 3,000 watts. Well, if 1 watt is 1 joule of energy transfer per second, then 3,000 watts means that every second the kettle transfers 3,000 joules of energy. Okay, so obviously a kettle, the input energy is electrical energy, and the output energy is heat energy, to heat in the water. So it transfers 3,000 joules of energy, electrical energy transferred into heat every second. Okay, assuming that it's 100% efficient. Okay, so that's what a watt means. Okay, so if we look at the part B of this question, it says an electric motor driven crane is used to raise a load of bricks of mass 700 kilograms through a vertical height of 8.5 meters in a time of 45 seconds. It gives you the efficiency of the crane. It says calculate the gravitational potential energy, EP, gained by the bricks. Well, gravitational potential energy is just mgh, mass times acceleration due to gravity times height. Okay, so we can just put in the numbers. This one's quite straightforward. We've got everything. So 700 times 8.5, sorry, times g, which is 9.81, sorry, times this 8.5, which is the height. Okay, if we plug that into our calculator, we get 5.84 times 10 to the 4, and that will be in joules. This isn't a measure of power. Gravitational potential energy is the number of joules, okay, if you raise a certain mass by a certain height. So it's definitely going to be in joules, the answer. Okay, so moving on to the next question. We've got to calculate now the output power of this motor-driven crane. Well, that's if we just write the equation for power. Okay, so power equals energy divided by time. We know that because we said power, the units that we use are watts, which is joules per second, so energy divided by time. Okay, we just need to work out the energy, which we've already got. It's going to be this, that's the energy, because it's the output power, so it's going to be, it is outputting, this is what it's doing with its output power. It's moving this 700 kilograms of bricks through 8.5 meters in 45 seconds, so this is its output power. So we just take our 5.84 times 10 to the 4, so P equals 5.84 times 10 to the 4, so I'll rewrite that, it's not very neat, times 10 to the 4 joules divided by the time. It does that in 45 seconds. Okay, if you type that into a calculator, you'll get 1.3 times 10 to the 3, so 1.3 times 10 to the 3. Now we're dealing with power, so that will be units of watts. Okay, so this is the output power, and now we've got to calculate the input power. Okay, we know the motor is 30% efficient. Okay, therefore the input power must be greater than this output power, because it's outputting this power by moving these bricks. 1.3 times 10 to the 3. If it's only 30% efficient, the input power must be much bigger than this number. How do we calculate that? Well, you just go 1.3 times 10 to the 3. If it's 30% efficient, if we therefore divide by 30, we'll get what 1% is, and then we just times by 100. Okay. If you do that, you'll get 4.3 times 10 to the 3, so 4.3 times 10 to the 3 watts. Okay, those of you that are a bit more that are more familiar with percentages, you can just see that you just can divide 1.3 times 10 to the 3 by 0.3. Okay, and it makes sense. Does this answer make sense? You should always continually ask yourself, do the answers you're putting down make sense? Because it's an easy check if you've made a mistake. This number must be bigger than this number, because this number is the output power, and we know that it's only 30% efficient, so the input power must be much bigger. Okay, so 4.3 times 10 to the 3 watts. Okay, I'll stop this video here and I'll continue with question 7 in the next part.